All right, now we are going to talk about cube roots. So they're very similar to square roots. If you remember, the square root of a number, like the square root of 9, is asking you what number is being multiplied by itself twice to get to that number. And for 9, the answer is 3. So with a cube root, we're asking you, like for in this example, what is the number when multiplied by itself 3 times will get you to that number. Okay? And then the symbol is just like the square root symbol, but it has a tiny 3 on the outside. So for 8, the answer would be 2 because 2 times 2 is 4, and then 4 times 2 is 8. So we say that 8 is the cube of 2, and 2 is the cube root of 8, because you're trying to figure out the root, the original. All right, so for instance, 1 cubed is equal to 1 because 1 times 1 times 1 will get you to that answer. The cube root of 1 is equal to 1. 3 cubed, 3 times 3 times 3 is equal to 27 because 3 times 3 is 9, 9 times 3 is 27. And then in reverse, the cube root of 27 gets you right back to 3. 4 cubed, 4 times 4 times 4 is equal to 64 because 4 times 4 is 16, 16 times 4 is 64. And the reverse, the cube root of 64 is equal to 4. Back to that again. Just like how we had perfect squares, we have perfect cubes. The perfect cubes are 1, 8, 27, 64, and so on. Okay? Because, for example, the square root of 8 is equal to 2 because 2 times 2 times 2 gets you to 8. So that's perfect. However, the cube root, should have put a little 3 over there. However, the cube root of 9 is not going to be perfect. Let's try that out in our calculator. Cube root of 9. It's that thing. 2.08 ... It actually goes on forever. So it's not what we call a perfect cube. Okay, let's go on and try our first problem together then. This problem is asking us to find the cube root of 216 by prime factorization. So they want us to figure out the cube root of 216. They could also write it like that. So just like before, we're going to find our prime factors. This is an even number, so I can cut it in half. 2 goes into 216. Let's see, 1 time evenly, then 1 doesn't go into 1, 2 goes into 16, 8 times. Okay, 2 is a prime number. I'm going to circle that. This can be halved again because it's a big number. 2 goes into 10 5 times, and then 2 goes into 8 4 times. Okay, oops, shouldn't have circled that. 54. 6 and 9, right? 6 times 9 is 54. And then 3 times 2 will get you to 6. Those are prime numbers. 9 is made up of 3 times 3. Okay, so these are our prime numbers. I have 1, 2, 3 2s and 1, 2, 3 3s. So before, when we were using prime factorization to find the square root, we divided them equally into 2 groups. Now that it's the cube root, we're just going to divide them equally into 3 groups. Okay, so I'm going to put one of the 2's in here, one of the 2's in here, one of the 2's in here. Put one of the 3's in here, one of the 3's in here, and one of the 3's in here. Perfect. So now I know that my answer is going to be whatever 2 times 3 is. 2 times 3 is 6. So my answer is 6 because 6 times 6 times 6 will get me to 216. The cube root of 216 is equal to 6. So since it's a cube root problem, you're dividing it equally into 3 groups. Previously, we had to divide our square root answer into 2 groups, right? When we had 4 2's and 2 3's, we divided them into 2 groups. I put 2 2's over here, 2 2's over here, to split them up evenly, and each of them gets a 3. Okay, that's for square roots. Now we're talking about cube roots. We have 3 groups. That's the only difference. Now, we do use cube roots when we're talking about volume. Previously, with square roots, we were talking about area, right? Because area is for a 2-dimensional figure. So all you're doing is multiplying the length times the length. Well, now we have a 3-dimensional figure. So instead of just a square that's flat on the table, we have a cube, like a box we can put stuff in. There's a 3rd dimension. There's actual depth inside that box. So we have 3 dimensions: the length, the width, and the height. Okay? Or sometimes people call it depth as well. So if they're telling us the volume is 3,375, and we know that the volume of a cube is this length times this length times this length, we need to work backwards. We have the answer. We need to work backwards to see what was multiplied by itself 3 times to get to that answer. Okay? So we're going to take 3,375 and we're going to find the factor tree for it. It's ending with a 5, so I know 5 goes into it. Let me take out my calculator so I don't make any mistakes. That's a big old number. 3,375 divided by 5 is equal to 675. Okay, I know I can divide that by 5 again. So I get 135 times 5. 5 is prime. 135 can be divided by 5 again. 27 and 5. 5 is prime. 27 is 3 and 9. 3 is prime. Break down that 9 into 2 3's. Okay, so now I have all my numbers. I have 1, 2, 3 5's and 3 2's. Perfect. I know I can have a 3 that goes into each of these boxes and a 5 that goes into each of these boxes because I have 3 of each. Don't forget my multiplication sign in there or else it's going to look like 35. So each number in there is 3 times 5. Let me rewrite these so they don't look like 3. 35. So in each of these boxes, it's 3 times 5 because I had 3 pairs of 3's and 3 pairs of 5's. Okay, so then that must mean that my answer is going to be 3 times 5, which is 15. 15 times 15 times 15 will get me 3,375. Let me double check that. 15. Ooh, I have a cube button here. Times 15 times 15 is 3,375. Perfect. That is my answer.